Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Welcome to the chapter 7 of computer programming CS103 course at GIK Institute offered by FCSE. Today in this chapter, we'll be discussing some very simple user-defined simple data types so that you can define your own data types. We'll be discussing the concept of namespaces. In particular, we'll be talking about the string type. So these are some of the topics that are important for today's lecture. You're already aware of the simple data types, and you're already aware you have been using the namespaces by adding the line using namespace std, and basically you also are already aware of the string type. But in this particular lecture, we'll go into more detail of these three main points. Let's start with what we're going to learn in chapter 7. In this chapter, you will learn how to create and manipulate your own simple data type, which we call the enumeration type. And enum is one of the most important data types, and it's one of the commonly used data type as well. And you'll notice how to make it and how to use it. You'll explore how the assignment statement and the arithmetic and relational operators work with the enum type. So you already know the assignment statement and the arithmetic operator, etc. They're working on the normal data types, but how do they work with enum type? We'll discuss that in this particular lecture. We learn how to use the for loops with enum type. So again, for loops are another important aspect, and how do we use them with enum? And that will be interesting to know. Then we learned how to input data into an enum type. So that's one of the important things. How do you assign data or input data into the enum? We learned how to output data stored in an enum type. So here output is an important factor for enum. We'll explore how to write functions to process the enum types. So functions for processing enum. We learn how to declare variables when defining the enumeration type. So how do we declare them as variables? We'll become familiar with anonymous types. So even other types will become, we'll like to know more. We'll become familiar with the typedef statement. So that's another statement that's very commonly used for defining a particular type. And then we'll also learn about the namespace mechanism. How does the namespace work? What are we actually doing when we are saying using namespace, std, or whatever? We'll then explore the string data type and learn how to use the string functions to manipulate strings. So this is something, part of which you have done already in the lab. But in this particular case, we'll be talking about string functions and how to manipulate them. So that will be the main task here. Okay, so what is an enumeration type? Well, it is to define an enumeration type, first we need to define what a data type is. So far, you have seen some built-in data types like int, characters, etc. A data type is basically defined as a set of values with a set of operations on them. So they have a particular set of values and a particular set of operations that are defined for them. For example, for int, the values may range from minus 3200 something to positive 3200 something. And they can have definite operations of, for example, addition, subtraction, division, multiplication, mod, etc. that are defined for them. So for each data type, there's a set of values defined, and then there's a set of operations that are defined on them. For characters, it is certainly different. The range, as well as the values, as well as the operations, everything differs. So for each data type, basically, each data type is nothing but a set of values along with a set of operations. So an enum type is basically a simple data type that is created by the programmer, by us, and hence this is our own data type. So if you want to make your own data type, you need to use the enum type. To define an enum type, you need a name for the data type, a set of values for the data type, and then a set of operations on the values. So of course, the name, values, and a set of operations. So you can actually specify the name and the values, but not the operations. So of course, what we can do is we can specify the name and the values, but not the operations. That's the limit on enum. The typical syntax for writing an enum data type is enum, type name, value 1, value 2, and so on. Value 1 and value 2 here are the identifiers, which we call the enumerators, right? So these are the enumerators of this enum. The name is basically type name. And the list here is basically which specifies the ordering as well. So this is the first identifier or first enumerator, second enumerator, third enumerator, and so on. And here's the ordering. So this one is going to be smaller than that, and value 2 is going to be smaller than value 3, and value 3 is going to be smaller than value 4. So this is also specific in terms of the ordering of the each enumerator. And remember, this is not necessarily integer ordering. This may basically be the ordering that you're giving. Whatever you're giving, you're basically specifying that this value is larger than that, although that this might be 1 and this might be 4, etc. We'll see how that works. The enumeration type is an ordered set of values. All the values are ordered. The default value assigned to enumerators starts at 0. So basically the first enumerator starts at 0. That's the value is 0. A value used in one enumeration type cannot be used by another in the same block. So you cannot give them the same values in the same block. And the same rule applies also to enumeration types declared outside of any block. So even if you declare a variable that's outside of any block, even then you cannot basically give them the same common enumeration type or value. So for example, the statement enum colors, brown, blue, red, green, yellow, define a new data type called colors, and the values belong to this data type are brown, blue, red, green, and yellow. You can notice that none of them is common, right? Similarly, the statement enum standing, freshman, sophomore, junior, or senior defines standing to be an enumeration type. So the name is standing. The values belonging to standing are freshman, sophomore, junior, and senior. So in the same order, they'll be defined for the standing enum type. So this is how declare the enum types. So let us consider the following statements. Enum grades A, B, C, D, F, for example. So if you do it like this, this is basically considered illegal. Why is this illegal? Because you cannot define it like these characters, right? Similarly, let's try enum places, first, second, third, fourth. This is also illegal. Why is this illegal? Because it contains two different things here. It contains a digit, it starts with a digit, and enum is not, in enum we're not allowed to start with a digit, right? So over here, for example, they're all proper names. So these are all legal. This one is illegal because it contains some characters. This one is illegal because it starts with a digit and then so on. So hence this is also illegal. So let us consider the following statements in example 7.4. Enum math student, John, Bill, Cindy, Lisa, and Ron, right? So now you declare a math student, which is basically John, Bill, Cindy, and Lisa, and Ron. Similarly, you've got enum comp student, Susan, Kathy, John, and William. So even this one is illegal because John has already been assigned to be being a math student. So this is illegal only. Also remember, this is illegal if it is declared in the same block. If it is in a different block, then of course this is legal. There's no issue here. But if it's in the same block, then of course John is a math student and John is also a computer science student. So it is not allowed because the value John was used in the previous enumeration type math student. The alternate here, if you want to actually declare John as both math student and computer student, would be to make a student class which contains only one of these names, right? And then in math student, you can then maybe register John as a math student as well as a computer student. But John cannot be part of two different enumeration types in the same block. That's the main issue here. So how do you declare variables? Well, the variables are declared in the same way as it is done for the for any common or simple data type. For example, the syntax here is data type identifier, comma, whatever it is. For example, you use int a, comma, b, comma, c, or whatever. So in that case, it is basically the int is the data type, a is the identifier, b is the identifier. Similarly, in this case, if you want to declare variables using enum, that's very simple. You first declare an enum. For example, in this case, we declare enum sports. Then we have got basketball, football, hockey, baseball, soccer, volleyball, etc. And these are basically are the values that can be held for each sport. The way we declare a variable of data type enum would be sports space, whatever identifier you want to give it. Just like you want int and you give it a name ABC or whatever, temp, right? So the same thing we're going to do here as well. And in this case, we are going to declare it as, instead of int, we actually write sports. So this part is what is my data type, right? Although sports is all, and then a data type of enum. In reality, all the data types that we're using, the default ones, are also enum, int, or something with the given values. However, in this case, the thing is very clear. Now, like there we use int, the same way we're going to use sports here. So for example, sports, popular sports, sports, my sport, or whatever, and then you can assign it whatever value you want out of these possible values. So how can values be assigned? Values can be assigned or stored in an enumeration data type by using this. So for example, popular sport, that was the one that we declared here, sports, popular sport, right? And next we can basically assign them the value, for example, football. So this one stores the football into the popular sport. So what are the possible, remember, the only possible values that can be stored in this enumeration type are either of these values. It can be basketball or football or hockey or baseball or soccer or volleyball, but nothing else, right? So if you try something at some other value, it won't be stored in this. So this one stores football into the popular sport. So what are the operations on enumeration types? Well, no arithmetic operations are allowed on enumeration types. So for example, you cannot add something, right? So you cannot add football plus soccer or popular sport plus 2. Even that basically means that plus plus and minus minus operators are illegal as well. So you cannot perform a plus plus or minus minus. However, if you want to do that, you need to use a static cast. So for example, popular sport is equal to static cast sports, popular sport plus 1. So this one actually adds something, but it does not allow you to store it. So the addition operator is working. Whatever is popular sport, you'll add the value 2 into it. So you get two values, two next values. For example, if it is football, in the previous step, then if you add to it, you get baseball, right? And once you get baseball, however, you cannot store baseball directly into, you cannot basically store baseball directly because this is an integer. Ultimately, when you add things, it becomes an integer, and an integer cannot be stored directly. So instead, what is done is that you're actually getting this integer popular sport plus 1, and then this is one step ahead, and then you are basically saying that convert it into sports and then store it into popular sport. So static cast sports is necessary to use this particular operation. Okay, an enumeration type is an ordered set of values. So of course it is an ordered set. For example, football is less than or equal to soccer is true. Hockey is greater than basketball is true, while baseball is less than football is false. So each type has its own, it's an ordered set, so it can be compared, right? So relational operators work fine with them. And an enumeration type is an integral data type and can be used in loops. It is also an integer, so that's the positive thing about it. Like I said in the previous example here, it acts as an integer, right? However, the problem here is that since it is an integer, we cannot store an integer directly into here. However, if we need to store a thing into the enum, we need to use the proper type as of it. So in this case, this did not work alone. Popular sports plus 2 is false. Popular sport plus 1 is false. However, if we use the static cast to sports, we can convert an integer to a sports value, and that can be hence be used. Similarly, when you use it inside, for example, in a loop like this, so my sport is equal to, let's initialize my sport with basketball. My sport, while my sport is less than or equal to soccer, my sport is equal to static cast sports plus 1. So now we can use everything we have learned about enum data type to define a for loop, and it's very easy. So basketball is basically the starting point. So if we go back to the example here, basketball is basically the 0th element, right? 0, 1, 2, 3, 4, 5, and until basically my sport is less than or equal to soccer. So until we reach the point, this point, we'll continue on the loop. So it will have the values possibly basketball, football, hockey, baseball, and soccer. Volleyball is missed. So now basically this is the second time, and then here we are basically doing the increment operation. The increment operation alone does not work. However, you need to use a static cast, and then you can increment it by 1 to get the next sport. Okay, so how do you define the input and output of the enumeration type? Well, an enumeration type cannot be input or output directly, so you cannot do it directly. However, you can do it indirectly. And what do I mean by indirectly? Well, here is the thing. Enum courses, algebra, basic, Pascal, CPP, philosophy, analysis, chemistry, and history, right? So that's how you define enum. Then you define the courses as registered. So these are the registered courses, right? So this is how you declare a variable, and then you switch to the value of registered, right? In case it is algebra, so in here some values being registered with it. In case it is algebra, we're going to see out algebra and break. In case it is analysis, see out analysis and break. And this is what we call an indirect output of your enum type, right? So this is an indirect enumeration. And for input, we know that already either you need to specify the exact value here directly. So courses registered is equal to algebra, or the other way would be to basically use a static cast and then use an integer with it. So another important topic is functions and enumeration types. So here is the thing. The enumeration types can be passed as parameters to functions either by value or by reference. So you can either pass the address here, or you can pass the enum type directly as a value. Similarly, a function can return a value of the enumeration type as well. It is allowed to have a return type of a value, where the return type is basically the enumeration type. So functions are compatible with enumeration types. You can use them as parameters in however way you want. They can be used as a reference parameter as well as value parameters. Similarly, a function can return the value of the enumeration type as well. So you can declare the variables of an enumeration type when you define enumeration type. For example, we can say enum grades A, B, C, D, F. So that's the way you define the enum type. And you can right here, you can define basically you can declare it right over here as well. Otherwise, you can basically use the grades, course grade to like the traditional way to define your to declare your variable course grade. So this also the other way is acceptable. Similarly, we have another data type which we call the anonymous type. Values are directly specified in the declaration with no type name. So for example, these are the anonymous types. Enum, notice here that there is no type name that is mentioned here, right? And we just specify basketball, football, baseball, hockey, and then my sport. So my sport then has an anonymous type, which is basically, but it can have a value basketball, football, baseball, and hockey. So these are what we call the anonymous data types. The drawbacks of using anonymous data types are that we cannot pass or return an anonymous type to or from a function. So an anonymous type cannot be passed to or from a function, so it does not work with functions at all. That's the problem with the anonymous data types. Then values used in one type can be used in another but are treated differently. So for example, we have got some languages defined here. So English, French, Spanish, German, Russian. So that's the advantage here actually, that we can actually have the same thing defined into different enums. So with an anonymous type, in two anonymous types, we can declare them in different, for example, some are languages and some are foreign languages. However, the values can then not be stored in across each other. However, the best practice and the best programming practice is to always define an enumeration type first and then declare variables later on, so that it looks very much like a normal simple data type, and the declaration and the variable declaration looks exactly the same as to that of a simple data type. Okay, so another different definition or another statement that is commonly used is to another practice is to create synonyms or aliases to a data type. For example, we can use a typedef statement in this particular manner: typedef existing type name and then the new type name to create an alias to it. Remember that typedef actually does not create any new data type. However, all it does is create an alias or shortcut to an existing data type. Sometimes the existing names are too long, and you might want to create aliases to it so that you can just use a short name for a really long type name. So typedef helps you define a short alias or a short name for a really long type name as well, and hence it is helpful in programming as well. So you can kind of like, by using alias, you can really use a lot of different type names for the and short names actually for the really long ones. Then if we talk about namespaces, the namespaces concept is relatively new. So the NC ISO standard C++ was officially approved in July 1998. The most recent compilers are compatible with NC ISO standard C++. So since this is the standard C++, the compilers that are made after that, in particular the Visual C++ compiler that we are using in Visual Studio, for example, the and the dev C++ compiler, the C++ 11 compiler, etc. Those C++ 11 language, etc. All of those are based on the standard NC ISO C++ language, and hence they are all compatible with the NC ISO standard C++. However, for the most part, well, the standard C++ and the NC ISO standard C++ are the same. Standard C++ was the one that was used before 1998, and every recent compiler is following these standards. However, there are some features in NC ISO standard C++ that are not available in standard C++. So there is something that is more in this particular. There are some more features present in NC ISO standard C++ that are not available in standard C++. So the global identifiers, for example, in a header file used in a program become global in the program. So if you have a header file and you're using global identifiers in that header file, they'll become global in the whole program. The syntax error occurs if a program's identifier has the same name as a global identifier in the header file. So you cannot have two global identifiers in the header file as well as that in the programs file, right? So we'll see what a header file is and what a program's identifier is. So the same problem can also occur with the third-party library. So if you've got a globally declared identifier, for example, cout or cin in a third-party library, well, we cannot use the same name cout and cin in our as a global identifier within our program as well. So one of the common solution is that the third-party vendors usually begin their global identifiers with underscore, and we do not begin an identifier in our program with underscore. So this is a good programming practice. Do not ever begin your identifier in our program with an underscore, because that is the common theme used by the third-party vendors. So whichever file you're including, whichever headers you're including, they may already have declared an underscore, a variable with the same name with an underscore. So, and do not, if you do not use underscore, we are kind of safe. So that is the common solution. Of course, if you're declaring a variable as global, you should try anywhere in the whole program. In other files, we'll see how to include other files as well later on. So do not, it's always a good practice to use names that are unique for global identifiers. The NC ISO standard C++ has attempted to solve this particular problem with the namespace mechanism. So it uses namespaces to kind of use the same variables, but you know, the same names for variables. Even if you declare it by mistake, for example, X is a common name. So what it does is that it kind of clarifies it by using the concept of namespace. And here's how you declare a namespace: namespace name, quotes, and the members of that, and followed by the ending braces. So here members consist of variable declarations, named constants, functions, or another namespace as well. So members can be, you know, variable declarations themselves, or named constants, or functions, or other namespaces. So this is how the namespace is defined in NC ISO standard C++. So here's an example. For example, we declare the namespace global type constant int n is equal to 10, constant double rate is equal to 7.5, int count is equal to 0, void print result, and this is the function, a signature here. It defines the global type to be a namespace, and it has got 4 members. One is a named constant int n and rate, right? So you've got n and rate as 2 named constants. You've got the variable count, so this one is allowed to vary. And finally, you've got a function which is print result, which is a void function. So a namespace member has scope local to the namespace. Each of these members is only accessible within this particular global type. So a namespace member can be accessed outside the namespace by using the namespace name and the scope resolution operator followed by the name of the identifier. For example, you can use the name, you can mention the name using namespace underscore name. If you use this one, right, then all you need to use to do is to directly use the identifier, just like we use using namespace std, and then std we don't need to use std double colon and cout operator that is generally used. So we don't need to use that. If you use the name, if you put the statement using namespace std at the top, then you don't need to do the std scope resolution operator and then the identifier, because we already know by including this particular line we are looking in std for this particular identifier. For example, if you want to use this namespace that we declared earlier, you need to write this global type rate, right? So global type rate to access it, or you can actually do using global type semicolon, and then instead of using the resolution operator, we can actually directly write the rate alone, and it will be identified directly into the global type. Similarly, you can use using namespace global type print result. If you want to use the print result function in some place, this then becomes accessible inside your code. However, the issue here is that the print result is again accessed through the scope resolution operator. After the using namespace statement, it is not necessary to put the namespace name this before the namespace member, like we do for std for cout. If you have the using statement like using namespace name, then you don't need to put this one before the namespace member, unless a namespace member and a global identifier or a block identifier have the same name. Of course, if it is in clash with a global identifier or a block identifier within the same scope, then you need to definitely mention the namespace member along with the resolution operator, so that we know that this is the exact member we are accessing and not the global identifier or the block identifier. This brings us then to another data type, which is the string data type, and you are already aware of the data type as such. But here we go in more detail about the string type. To use data type string, a program must include the header file string. So we know this already. A string is a sequence of 0 or more characters. The first character is in position 0, the second character is in position 1, and so on. So you've got at least a sequence. You've got a sequence of few characters. The binary operator plus actually performs the string concatenation operation. So if you use plus between two string types, it is going to concatenate them, put them together. An array subscript operator, this allows access to an individual character in a string. So this is what we're going to study in arrays later on. But you can use the same subscript operator to actually access an individual character in an array. So for example, if you mention 0, you're going to access the first position. If you access first character in the string, if you put in the index 1 here inside it, like this. So if you put a 1 here, this is going to access the second position and second character of the string, and so on. If you use the plus operator, it is going to put both of them together and concatenate them, put them together. So some further operations are, for example, the size type operator that is defined for string. Again, using namespace string, this is going to be defined by default. So this is, if you include the header file string, this size type is already accessible, and this is basically an unsigned integer data type, right? So size type is an unsigned integer data type. Similarly, you've got the npos defined, which is basically the maximum value of the data type string size type, a number such as this on many machines. So again, this is the maximum number that can be stored, or the maximum value of the data type that can be stored in string, which is typically 4294967295, but it may have a different value depending on your machine. So for example, let's take the swap function that is available inside the string value. So for example, we declare string 1 as string str1 is equal to warm and string str2 is equal to cold. So in this case, after the following statements, str1.swap and string 2 is executed, the value of string 1 is going to be basically cold. So cold is stored in string 1, and the value of string 2 will now become warm. So that both the values have been swapped between string 1 and string 2. It is equivalent to the statement string 2 str2 dot swap string 1, and that performs exactly the same thing. So the swap function actually swaps the value of one string with the other string and replaces, it just swaps them. It is just like the quiz that you did for when you were supposed to swap the values of two variables. So to summarize, and these are some of the functions here. Of course, there are many more functions. You might have observed the length function, get length function, and other things. And I'm not going to talk about them right now. But if you go through the book, you can find again all the different functions here that are useful for you. And since this is just the introductory lecture, you will have to go through the chapter 7 of the book to understand these concepts even further. So in order to summarize the whole lecture, we can actually, we have studied enumeration type, which is a set of ordered values, and a reserved word enum creates an enumeration type. This is how you define or create an enumeration type. Then you can declare the variables using the enumeration type name that you have used. No arithmetic operations are allowed on the enumeration type directly, actually, so you cannot directly add or do any other arithmetic operation. However, relational operators can be used with enum type, so you can have less than or greater than, etc. Comparisons being made. Enumeration type values cannot be input or output directly, so you cannot get enumeration type values as input directly or as output directly. However, with functions, they can work both by value or by reference. So that's a good thing. They can be passed to as parameters, and simply they can be retrieved from functions as well. So we studied another type, which is anonymous type, where a variable's values are specified without any type name. The good thing about it is that it allows you to use the same enumeration type in different enums. However, the bad thing is that it cannot be passed to a function, or the values cannot be returned from a function for an anonymous type. The reserved word typedef creates synonyms or aliases to previous defined data types. So in case you want to write a short name for a data type, you can use the reserved word typedef. The namespace mechanism is a feature of NC ISO standard C++. So by using namespaces, we actually are able to differentiate between a global variable and a global variable that is coming from a specific namespace. A namespace member is usually a named constant, variable, function, or another namespace. So the member, as we have seen, for namespace can be a named constant, a variable, a function, or it could possibly be another namespace. The scope of a namespace member is local to a namespace. So all the namespace members are visible only to the namespace. Only if you include the namespace somehow by using a command, or by declaring it along with the namespace, only then you can access the namespace member, as we'll see in the many examples in the code. So the using statement simplifies access to namespace members. You write it once, and then you can directly access the members unless there is a clash with a global or a local member of the same block. A string is a sequence of 0 or more characters. So we saw the string data type. It is basically a sequence of 0 or more characters strung together. Strings in C++ are always enclosed in double quotes. The first character of a string is in position 0. In C++, the array index is or array subscript operator is used to access a particular character starting from position 0 to position n-1 to access characters. And then there are many different built-in functions like swap, like getLength, setLength, etc. Other functions which can be used or accessed through the dot operator with strings, and it helps you perform a lot of different particular things with C++. So these are the built-in functions that are available and can be used by just by using the dot operator. So this brings an end to the lecture part of this chapter. We'll now shift to the code part and see some examples for this particular chapter. So I'm now shifting to the code part, and you can actually see the second part of the lecture, which gives the code and the examples for this particular chapter.